Within group or repeated measures designs. Now, another type of factorial design is a within group design. Within group and repeated measures are terms that are interchangeable, but they say the same thing. The within group design is where we have the subjects are exposed to all of the different treatments throughout the length of the study. So that's why they call it a repeated measures, because over time, the subjects have the measurement taken multiple times after they've undergone the various treatments. In a within group repeated measures design, obviously, the subjects are going to be exposed to all the levels of a factor. So if I have one factor with 3 levels, 3 different treatment types, the subjects are going to do each of the treatments and then have a measurement taken. Because of the learning effect, we talked about this in the previous unit, because of the potential of a learning effect, the fact that when they're tested or measured multiple times, that they may perform better as they learn or get better at doing the task, we randomize the treatment order typically. So if there are 3 treatments, a vibrating foam roller, a non-vibrating foam roller, and a control group, and we're going to have the people do each of the different training techniques, then or use the different foam rollers, we would do it in random order. So if I have 30 subjects in this study, 10 of them would do, or some of them would do this treatment first, some would do that treatment first, and so on. So that they're randomly exposed to the order of the different factors. That helps to minimize the risk of a learning effect. This single factor a within groups repeated measure design can be examining a single factor with multiple levels, or it can examine multiple factors and so on. So again, we can see single factor repeated measures designs or multi-factor repeated measure design. If one factor is used or studied, an ANOVA is performed. If it's a multi-factor, then a factorial ANOVA, multi-factor ANOVA would be used. And then if we have multiple dependent variables, a MANOVA would be used, which is exactly the same as what we do in a between groups design. If differences are found, again, post hoc testing would be done to examine those differences. So the biggest difference here in a within groups study is that the subjects are exposed to each of the treatments. Statistically, this is a stronger design than a between groups study because you're comparing one subject's performance after a treatment to the same subject's performance after a different treatment. So we don't run the risk of, hey, maybe we put all the people that perform or respond better in one group by random chance. We remove that risk. So a strength of this study is that statistically we're comparing one person's performance to their own performance in a different treatment, but we also run the risk of there being a learning effect. So there are advantages and disadvantages to each design. If I'm doing a training study where I'm training people over 6 weeks, it becomes really hard to do a repeated measures design because we have to wait until the effects of the 6-week training run off if we're going to do a repeated measures on those subjects and then train them for another 6 weeks. So it makes for a really lengthy project if we do it that way. So again, there are advantages and disadvantages to each design. But let's take a look at an example of a repeated measures or within group experiment. I liked this study because they gave us this nice little chart sort of showing how the subjects were treated throughout the length of the study. This study is titled Crossover Effects of Unilateral Static Stretching and Foam Rolling on Contralateral Hamstring Flexibility and Strength. So what they did in this study, kind of neat, right? They trained or they did all of the treatments on one leg, on the hamstring of one leg, but then measured the effects on the hamstring of the opposite leg that was not trained. So what they did in this study was they utilized a couple different types of programs. They had static stretching as one measure, foam rolling as another measure, and then a control group. And what they did was they had their subjects come in on visit 1, and they got familiarized with the foam rolling program. They got familiarized with the strength training and flexibility measures that they were going to do. And we often see that familiarization visit in repeated measure design, because what it does is it allows us to have the subjects do the tests in advance, minimizing the learning effect. So they're familiar and trained on how to do the straight leg raise test and the strength testing test, so that there is less of a chance of a learning effect. They then performed their testing on 2 different visits. They would then come in and do the testing once under one condition, and then a second time under the second condition. They would have these measures taken after each one, and so on. And the order of the treatments was randomized among the participants. So half the people did the static stretching treatment the first time they came for treatment. The other half did the foam rolling. So what did they find? What they found was that when we look at the static stretching group and we looked at range of motion in these individuals, we found that in the static stretching group, when we compared pre versus post, a statistically significant difference in hamstring flexibility when we compared these 2 groups. And again, this is in the non-trained leg. So there was a crossover effect. When we train and do static stretching on one leg, we see a significant improvement in the other leg. We saw similar effects in the foam rolling group, that we saw an increase in flexibility in the non-treated leg. However, the difference pre and post was less than we saw in the static stretching group. So what this tells us is that static stretching of one leg will affect potentially the flexibility of the other leg. And if our goal is to improve range of motion, that the static stretching may be a better way to do it, although both techniques are going to be effective. As I stated, we see in our literature, in fitness and wellness, human performance studies, we see a lot of factorial designs, whether they be between group or within group, if they involve multi-factors or multi-dependent variables. We see these types of studies a lot. So it really is important for all of us to get good at reading them, because they tell us a lot of very useful, very practical things. These are the types of studies that are used to evaluate the effects of training programs on groups of people, on different types of interventions. They also are used to examine just differences that exist between groups, or the types of demands that are placed upon athletes in various positions within our sports teams. All of this information can be really important in helping us design the most effective training programs and help our athletes, our clients, improve their movement, reduce the risk for injury, and improve overall human performance, which is what I think we're all in this for. So I really encourage you to get good at looking at these articles and not just reading the abstracts, but looking at how they measured their subjects, how they divided them into groups, and seeing how they examined the effects and the interactions that can occur between the different factors that they were interested in. Anyway, we went over a lot in this presentation. I tried to make it more practical by utilizing a lot of studies in our field in areas that I think are of interest to people that are interested in human movement and injury prevention and so on. So they're all listed here. Where possible, I'll provide links to each of these articles or the actual articles themselves in case you want to jump in there and really take a look at what they found in any of these particular articles. Anyway, that's it for this series of presentations. Hopefully you learned a lot about Factorial Designs. If you have any questions, please never hesitate to shoot me an email.